So in this video, I'm going to go through and derive the quadratic formula, which is this one here, using a technique known as completing the squares. So just as a quick bit of background, remember that if you have a Cartesian coordinate system, so x and y, and you have a quadratic plotted on it, when you use the quadratic formula, what you're trying to find is where that quadratic crosses the x-axis, so like these 2 points here. So if we take a general form of our quadratic, so the y equals ax squared plus bx plus c, where a, b, and c are constants, what we're trying to find is where y, is equal to 0. So that's how we're going to start it off. Okay, so we're looking for y equals 0, and we need to figure out what x is at those points. Okay, so we're going to end up with 0 is equal to ax squared plus bx plus c. So now our goal is to rearrange this equation to get x on its own, okay, which is what the quadratic formula actually is. So this is where we start to apply that technique known as completing the squares. So what I'm going to do firstly is divide everything by a, okay. The reason is a is a constant, and I can make my life a lot simpler if I just have a 1 in front of the x. So 0 divided by a would just be 0. A divided by a is 1, which is what I'm looking for, just a 1 in front of the x. Dividing this term by a, and then dividing the last one by a. This is what I get. So in my other video, which I'd recommend you going back and referring to if you're unclear on this completing the squares technique, but what we want to do is just essentially replace this x squared plus b on ax with something that has x plus a constant here in brackets all squared. And how we get what this constant needs to be is we look at this term here, b on a, and we divide it by 2. So that means we'd end up with b over 2a. And what we should find is if we expand this out, we should end up with the x squared and the b on a x terms falling out. So remembering that we have this rule or identity, I made a mistake, equals, in order to help us out in the expansion. So applying it here, we're going to end up with x squared plus 2x times b over 2a plus b over 2a all squared. So if we clean it, 2 cancels with 2, and we end up with b on a times x. And expanding this, remember the squared needs to apply to everything. So we get b squared on the top line, and then 2 squared is 4. And a squared is a squared. And what we see here is that the x squared plus b on ax matches with what we have over here, which is what I was looking for. So now what I want to do is I want to make this match up with what we have here. So if I carry my first 2 terms across, all right, they match up straight away, but we can see we have this extra part on the end. So how I get around that is I'm going to add it. But then to make sure my lines remain equal, I'm going to also take it away. So it's like adding 1 minus 1, nothing happens overall. And then I need to carry through this c on a as well. And what we can see here is that now this first 3 terms match up to what we had over here. So I can just replace it with this bracketed bit, all right? And that's the completed squares part. Right, and we still need to carry across this other stuff, otherwise it's not going to be equal. Alright, so what we can see has actually happened here is I've now just got a single x in the equation, and I just now need to rearrange to get that x on its own. Whereas before you could see that we had an x tied up in a squared and on its own, so it wasn't really possible to rearrange from there directly to get x on its own. So once you're at this point, it's all just manipulation. So what I might do as a first step is move these 2 terms to the other side of the equation. So we end up with b squared on 4a squared minus c on a is equal to the part that I'm leaving. And what I might do next to make it nice is try and get all of this into just one fraction. So for that to happen, I need to have the denominators being the same. So the lowest common denominator here is going to be 4a squared. So I need to get this to be 4a squared as well. So if I multiply the bottom line here by 4a, all right, that's going to be the 4a squared. And to keep it equal, I need to multiply the top line by 4a as well, because these just cancel and it's just like multiplying by 1, which again does nothing, it just remains equal. So now that I've done that, we've got a common denominator here. I'll write it out neatly. This becomes 4ac on the top, 4a squared. So we can put these together, and that means we just copy across what's on the top line. So b squared minus 4ac all over that common denominator. Our right hand side is just remaining the same. We haven't done anything to it yet. Alright, so next up, I want to try and get this x on its own. So I think the best thing to do would be to undo the square. And to do that, we need to take the square root of the other side of the equation. So, taking the square root here, we get that, and of course it undoes here, so we're just left with the b on 2a. And one trick is, remember that when you take a square root, either the positive or the negative of that root is required, okay? Because remember, 2 times 2 is equal to 4, but also negative 2 times negative 2 is equal to 4. So you can have either the positive or the negative of your root as a solution. So now I'm going to try and get x on its own, which means we have to move this to the other side. So I'm going to stick it out the front. It's going to go negative when it shifts to the other side of the equation. And all of this just remains the same. And it's equal to x. Okay, so we've successfully got x on its own. The only last little bit to do to make it look exactly like what we had up the top is we need to kind of go back and get the 2a out. So we can do that for here. We can apply the square root on the top line and the bottom line. Alright, and we can take the square root of 4a squared quite easily. So top line, not much we can do, but the bottom line, if we square root all of this, the square root of 4 is 2, and the square root of a squared is a. So last step is that we've got a 2a here and a 2a here, so that's like our common denominator again. So I'll flip it around and we can pick up everything on the top line. And then the bottom line, we just take our common denominator, which is 2a. So this here is the quadratic formula. So there you go, that's one way of deriving it, using that completing the square technique.